Hi everyone, welcome back to Job One for All. In this video, we are going to talk about the LinkedTransferQueue. So create a class LinkedTransferQueue test01, and this class, it's interesting because it's basically the merge. It's the result of merging three different collections. One is the concurrent linked queue. The second one is the synchronous queue. And the third one is the linked blocking queue. So basically the guys got all these three, the functionality of these three collections, and they put together into one. That's the linked transfer queue. So let's create here transfer queue, string, to key, to queue, new linked transfer queue. So this one does not accept capacity, but there is a capacity. If you call remaining capacity, you will see that we have quite big capacity inside this queue. So what's available for us? So basically you have several options, from like blocking to non-blocking, from throwing exceptions or returning booleans or nulls in case you don't find anything. So for example, we have this add. So when you try to add, the behavior is it will insert in this queue if it's possible to do it immediately without violating capacity restrictions, and it will return true or throw illegal state exception. So basically, if there is no capacity for you to add this element, it will just throw illegal state exception. But what if you don't want to throw illegal state exception if you cannot add? You have another method that's called offer. So basically, the offer, it will return false if there is no space currently available. So when you're using capacity restricted queue, this method is usually preferable to instead of the add. And the offer has another flavor, that is the offer with some time to wait. So basically, this one we have to handle the interrupted exception. We'll try to insert, and for example, there's no space available, it will wait for the specified time, these 10 seconds that we pass here. So when you execute, Ctrl Shift F10, so as you can see, true, we were able to insert three elements, include this one immediately because, well, the size is quite big. Another one that we have is the but. Now, the but, as we saw at the previous video, it will insert, and if there is no space available, it will keep waiting until someone comes, another thread, and calls the take. And once it's available, it will release, and it will put this value inside. Now, there is another one that's quite interesting. That's the behavior of the synchronous queue. So if you want, for example, at the moment you insert something, you want to immediately wait for someone to consume, you have this transfer. So basically, if you try to use this transfer, it will waiting for it if there is no consumer. So if you try to execute now, you will see that the code will get blocked. Why? Because there is no consumer to get this element that I'm trying to add. So the transfer, it waits for the consumer. If you want to check if there is consumer, you can call toKey.has waiting consumer. Or another option for you is to call the try transfer. toKey.try transfer. So this one, it will try to transfer if there is a consumer waiting for it, basically immediately. And if there is no consumer waiting, it will return false. So you can see here, if we execute again, it will return false because there is no consumer waiting for it to transfer. If you would like to wait, let's say I want to wait for 5 seconds until maybe a consumer will show up, you have this option. So this will block for 5 seconds, and if nobody tries to consume between this time frame, it will just throw, actually return false, not throw anything. And we have, continuing, TQ.element. So basically the element, it will retrieve, but it will not remove the head of this queue. So the difference between the pick is that this one will throw an exception if the queue is empty. And if we have the element, we have the pick. Basically the pick will return no if the queue is empty. So that's the difference between element and pick. And we have poll. Basically the poll, it will retrieve and remove, or is going to return no if the queue is empty. But what if you want to throw exception if the queue is empty? You have the remove. So basically the remove is similar to the poll, but the difference is that it will throw exception if the queue is empty. And the last one, you already know how it works, is the take. So the take, as we saw before, it will either just take whatever is available, or it will keep waiting until any element becomes available in that queue. So basically that's the linked transfer queue. One thing that I would like to say is, if you are working with concurrent collections, as much as possible, try to use the ones available from newer packages. So for example, the linked transfer queue was developed at 1.7. So when you try to use the ones that are newer, the chance that you will have like a better code or better performance are higher. It's not that it's wrong to use, but usually people get a lot of experience from previous errors or from different customers using the code. So in newer versions, you always have some kind of improvement. Okay, so that's it for the linked transfer queue. Let's continue with more topics in the next video. Bye.